Good day, everybody. I hope you're all fine. Welcome back to my channel. Please do not forget to subscribe, like, and share. So today now we'll be doing grade 10 trigonometry. Okay. So now what is happening here? It is that you are just gonna do the introduction. So now basically trigonometry can be found in many fields. Like I'm not talking about career things like engineering, surveying, blah blah blah, architecture. And then what you have to know it is that this topic, it is what the study of the relationship between what angles. So the main thing to know is what we will be dealing with, what with angles and the lengths of the sides of triangles. So we'll be dealing with triangles, the angles of triangles, etc. Okay, and then the most angles that you're gonna use at these ones, we have what you call theta. This one is theta. The second one will be beta. And then the next one will be what? Alpha. Okay, so this will be the common angles that you're gonna find in this topic. So now check something. Let's start. Now under trigonometry, we use what? Right angled triangles. Remember, right angled triangle, you started it in grade 8 whereby you're doing theorem of Pythagoras, which describes the relationship between the three sides of a right angled triangle. So now you will be applying that knowledge from grade 8 and now applying it here. And then now this is our right angle triangle. So I have A here, and then this, can you see it? Whereby I know that the length, the longer side, which is c squared, is equals to what? A squared plus b squared. Okay, that's what you have to know. But now, since now it is the higher grade after grade after grade 8, we will label the three sides as adjacent, opposite, and hypotenuse. The longest side, which is this one, will be the what? Which is opposite to the right angle, is the hypotenuse. And then the opposite and adjacent sides are dependent on which the angle is used as the reference point. What am I talking about? This is an example of what I'm talking about. So here you'll be having A, and then here we'll be having, let me say, B here, and then C here. And then now it is gonna be what? The right angled. Then now here, this is where you're gonna find what? The angle, which is B, which is theta, beta, or alpha. So these ones will be here and here. You can find them here and here. Is it fine? So now I said the longer side, it is what? The hypotenuse. So this one, it is what? Hypotenuse. You call it what? The hypotenuse. And then now this one, now check something. This AB, it is opposite to B. So this side, we call it what? Opposite. So this side, it is the opposite one. So we call it opposite because it is opposite to B. And then this one, it is what? Adjacent to B. Okay, so basically this side, it is the adjacent, this one is the opposite, that one is the hypotenuse. That's how you can understand it. Is it fine? So now in this grade, we have what you call trigonometric ratios. Trigonometric ratios. So there are three special ratios in the study of trigonometry, which we call what? Sine. But in our questions and everything, we simply write it as sine. And then now the second one, it is what? Cosine in full weight, but on our study and questions we'll call it cos. And then we have what? Tangent. So ratios, but in our study we call it what? Tan. Is it fine? Those are the three ratios that you're gonna use until grade 12 and until further grades and stuff. So when the three ratios are applied to a right angle, they define the relationship between its sides and angles. Okay, so now let's go for some few examples where you're simply gonna understand these things. So now let me simply just what you call summarize each and everything, because some things in maths, if you try to know the theory and everything behind it, you might end up being confused. That's why I'm simply gonna summarize everything for you. So now sine, it is usually written as sine theta. Okay, so this sine theta, it is equals to opposite over hypotenuse. Is it fine? That's how you express what? Sine theta. Is it fine? And then now cos theta, this is cos theta. Cos theta, it is equals to adjacent over hypotenuse. What do I mean by that? Let's say I'm gonna use this. Let me do this one. Then maybe I have A, B, C. Okay, and then here maybe I'll be having my right angle thing and then my angles there. Is it fine? So now maybe let's say here I have P, here I have Z, here I have R. Now let me just say M. So now basically on this triangle, it is sine theta. So it basically means according to that triangle, I have opposite. What is my opposite? It is M over hypotenuse, which is Z. And you must be careful, guys. Make sure that whenever you are writing the trigonometric graphs and everything, I mean the trigonometric triangles and everything, the right angle triangle, make sure that it is in this form, because they can try to trick you and write it like that, like something like this. They can put something like this and then they'll say 90 and then angle here and whatever. So you'll have to understand and know that since this is my 90, this is the adjacent side. Since this is 90, this is the opposite side, and the longer side, it is the hypotenuse. You have to understand that even if it is like this, then they put 90 here, and then you have to know that if the angle is here, this one is my adjacent, this one is my hypotenuse, this one is my opposite. It is not always the case whereby you will find opposite or whatever. So you have to rearrange your triangle. Okay, and then now since this is M over Z, let's continue. I can see that my triangle is good. So now cos theta, it is adjacent over hypotenuse, and I said that adjacent, it is this here, meaning that adjacent, like the right angle, it is now facing each other with what? With the main angle there. So now this is what you have. We have P over Z, and then now for tan, it is simply tan theta equals to opposite over adjacent, which is now the same as what? M over P. Okay, so now how will you cram the whole thing, like sine theta is opposite of hypotenuse, blah blah blah? You simply write so ka toa. This is simple. You can even know it for the rest of your life. So ka toa. So now this is what you call the trigonometric things that we did, whereby I told you that we used the angles, namely theta, beta, and alpha. You are going to use them in the questions. And then at the same time, I told you that you have to know that you are going to use the right angle triangle. Okay, so now let's discuss this thing. How are you going to know that sine theta is opposite of hypotenuse, cos theta is this and this and this and that? Check. The first one, the first three letters, it is so, meaning that S for sine, O for opposite, H for hypotenuse. Can you see it? C for cos, A for adjacent, H for hypotenuse. T for tan, O for opposite, A over adjacent, A for adjacent. So now that's how you can know all those things. Okay, and make sure that whenever you're given a triangle like this, make sure that you rearrange it and write it in a form of like a normal right angle triangle. Okay, because they can try and trick you and put something like this. You'll have to rearrange it and put something like this so that you can know what to do when you're choosing the values of your sine theta, cos theta, and tan theta, just like that. Okay, so now after making sure that you rearrange your triangle, maybe if they give you like this, make sure that it is like this so that you can be able to understand and choose the sine theta, cos theta, and tan theta. And know that so katoa, it is the best way to remember that sine theta is this and this one is this and this one is this and that, because S for sine, O for opposite, H for hypotenuse. So O over this, A over this, O over A. You see, that's how it is. So now let's just check some few examples and then yeah. Here is a nice and introductory example. The first one is saying determine DF. So basically they want the length of DF. And the first thing first, check if your triangle is good. Yeah, it's a normal right angle triangle. Okay, so now they want the length of DF, and I can see that DF, it is the longer side, meaning that I simply gonna have DF squared equals to 5 squared plus 12 squared. because it is DE squared plus EF squared. You see, just summarizing, then I know that my square root of DF, it is equals to the square root of 25 plus 144. Therefore my DF, it is equals to 25 plus 144. It is it is 169. Then the square root of 169, it is equals to 13. Then my DF, it is 13 centimeter. Is it fine? So you're done with number 1. Then number 2 says that write down the values for sine theta, cos theta, and tan theta. So sine theta, cos theta, tan theta. So now we know that sine theta, it is equals to what? Opposite over hypotenuse. Isn't that? So you know that sine theta is equals to opposite over hyp. Then what is my opposite? 5. What is my hypotenuse? 13. You see, that's my answer. And there's something that you have to know, guys. If you made a mistake here on finding the length there or the hypotenuse, no, that everything is wrong, because I just used 13 here because it was my answer. And then now let's go for cos. Cos, we know that it is whenever you have an equation, write SOHCAHTOA so that you can remember. Cos, it is simply adjacent over hyp, which is equals to 12 over 13. Already on the second question, you are still using what? The same question, the same answer you got. Tan theta, it is what? Opposite over arch. That is the shortened, the best way to write it in short. So opposite, it is what? 5 over 12. You see, this one is better because it just took what we were given. So now this is how you can do it. We are given the triangle whereby we had to find the length of the higher DF. So I found the length of DF as 13 centimeters because it is the longer side. And then now they said that they want the values of sine theta, cos theta, tan theta. So you had to write SOHCAHTOA and then say opposite over hypotenuse, 5 over 13, and then cos. You see, that's how it is. Then the next one says write down the values of sine beta. Now they want sine beta, cos beta, and tan beta. And check, where is my beta? It is here. So now for you to make life easier for you, this is what you can do. Simply redraw the same diagram, the same triangle, but now you're going to change the angle. Remember, this was the main angle on the triangle. So now where there's theta, you're simply going to put beta, and you're not going to put 90 here, then theta. But now check something. What was the length between theta and 90? It was EF, which is 12. So meaning that where there is theta, I'm going to put what? Where there is theta, I'm going to put what? F. Where there is 90, I'm going to put what? E. Can you see that what I'm talking about? And then meaning that here I have what? D. So basically this is just this. Can you see it? It is basically, you just flipped it now. Can you see it? And then now let's go. So you have F, E, D, just like that. Wait, at beta there was D, okay? At theta there was F, and then yes, that's how it is. That's how it is. So now let's start. The one sine beta. Sine beta, it is equals to what? Opposite over, let me label here, I have 12. ED, what is ED? ED, it is 5. And then EF, it is 12. Then this one doesn't change, it is just 13. Is it fine? So now what is what you call sine theta? Sine theta, it is just opposite over hypotenuse. But now we are dealing with sine beta. So sine beta, it is going to be opposite, which is what? 12 over 13. Can you see now the difference? And then cos theta, it is adjacent over hypotenuse. What is my adjacent in this case? It is 5, then 13. Then tan beta. Now tan beta, it is opposite over adjacent, meaning that it is what? 12 over 5. Can you see it? So guys, this was the triangle that we're given there. So you simply had to start by calculating the length of DF and found it there. And as you can see, the main angle was theta there. So now they said they want values of sine theta, cos theta, and tan theta. So since it was in terms of theta, the triangle is fine. I do not need to flip it or do anything. So I had to write my what? SOHCAHTOA, so that you can remember that sine theta is opposite of a hypotenuse. This one is adjacent hypotenuse, opposite adjacent. Then I got my answers there. Now, the third question was saying they want sine beta now, meaning that you had to change the triangle you can flip it. So where there is you simply had to make beta the main angle there and then change some few things, and then that's how I got my answers. Okay, so thank you very much guys. I hope you enjoyed and learned a lot. Thank you.